So again, we'll start with this. If I'm going to make a line of best fit, the first thing I have to do is the scatter plot, which means I'm just going to take these values and place them on this graph. Okay? Notice I'm going up by 200 in thousands. So this is the number of employees in 200, and it's measured in hundred and thousands. So this is 200,000, 400,000, 600,000, and so on. Okay? This is also listed in thousands as well, though. So, 581 would be 581 on this graph. Okay? And then our years are going by fives here. Notice fives is every other. So make sure when you're making a scatter plot that you're always really careful about how the graph is labeled. Okay? Now, so the first plot point I want to plot is 1980 and 1027. So I need to go over 1980. 1027 is going to be just a little over 1,000. Because if you think this is 1,100, so 1027 is going to be, maybe about like here, maybe like a fourth of the way up. Or maybe, probably not even that much, like an eighth of the way up. So go ahead and graph that point on there. And again, you guys should be following along and doing this on your 8-9 skills practice, so that way this is your notes. So we're going to put one value right around here. Then we have 1985. So I've got my first point. It didn't show up very dark. So my first point there, 1985. Make sure you don't put it on the next line, because what year is this? Right, this is like 1982 and a half. So that you don't want to put it here. You want to make sure you put it over 1985. And there, the number of employees is 927,000. So that's going to be, if 900 is halfway between 800 and 1,000, so that'd be somewhere around here, just a little bit higher than halfway, because it's 927. So a little closer to 1,000. So you'll put that value in. Then we have 1990 again, not this one, this line here, and our value is 709. So where's that going to be? Halfway between 600 and 800, right? So you want to put another point right there. Then we have 1995, again, skip one. 95, it is 581, so that is, it's pretty darn close to 600, right? It's only 20 less than 600, so it's going to be pretty close to the 600 line there. And then in the year 2000, we have 475. So that's pretty close to 500, which would be right in the middle. So it's going to be a little less than the middle. And then the last one we have is 2005, and our value is 318, which would be a little higher, not very much, but a little higher than the middle between 200 and 400, right? So our first step is to make the scatter plot, and then we need to draw our line of best fit. Remember, your line of best fit is not going through all the points. Do not draw a line of best fit like this. I have students who've done this before. They'll go, what's the problem with that? It's not a line, okay? A mathematical definition of a line is the shortest distance between 2 points, which means it has to be straight. It cannot be this way then that way, because the shortest distance between this point and this point is definitely not this route, right? Okay, so this is not a line, thus it is not the line of best fit, okay? So the line of best fit, you want a straight line that crosses as close to the points. Again, don't just like connect the first 2 points, because does that really fit the data? No, you want to draw the line wherever it kind of goes closest between as many points as you can possibly get it. You know, if you have, just like in mean, median, mode stuff, you can have an outlier in a line of best fit. If you had like a certain year that, you know, this is people employed in mining, well, you know, say there was, you know, a year that, you know, they laid a ton of people off and all of a sudden it went way down, but then it came back up, that number might be an outlier. So if there's one value that's like not anywhere close, you can see all these points kind of lay along the line, right? If you had one that was like way down here, you would just kind of ignore it and just try and make the line fit most of the rest of the data.
Is there any work I can get on stuff?
Okay, so here I have this line. Does this line fit the data fairly well?
Yes.
Could you draw a different line that also fit the data fairly well? Yeah, I mean, if I take this line and I, you know, maybe move it like up a hair. Does that fit the data fairly well?
Yeah.
Yeah, okay. So again, line of best fit is not going to be exact. Your line of best fit, my line of best fit, will not necessarily be exactly the same thing. This is not exact, okay? But this is something where, you know, I can check and see if your answers are around what I would expect them to be. So I'm going to put this line of best fit right there. Now I kind of try and put it in the middle. Notice what points are actually on my line of best fit. Paris? 1980. That one's fairly close. But is it actually on the line? What about that one? That one? That one? That one? That one? Okay, so line of best fit here isn't actually going through any of my points. Because if I wanted to make it go through points, then I'd move it down here, then these ones up here would be further off. And if I moved it up to match those ones, then these ones that are below. So if I can see, I've got like 3 points that are above the line, 3 points that are below. So if I moved it up to try and make some of them be on the line, then other ones would be further away. And if I moved it down to get those ones on the line, then the other ones would be further away. So the line of best fit does not actually have to include any of the actual points. The point is to come as close as possible, which means you're meeting in the middle, which means sometimes your line is going to be in the middle, okay? Now, for the point of finding an equation, we'll look for the 2 points that are closest to being on the line. So, you know, I would probably pick like that one here and that one here because they're both fairly close. Dolan? Yeah, I'll let you do that during connections time today. So, all right. So anyway, the first thing they ask us to do after we do our scatter plot is to write an equation for the line. So just like what we were doing in section 8.8, to find an equation for the line, we need what first? Slope, okay? So to find the slope of this line, I can find 2 points that are on the line and do y2 minus y1 over x2 minus x1, right? So like I said, I picked these 2 points over 1980 and 1995 because they were the ones that were closest to being on the line from what I could see. So if I use, so 80 and 95 means I'm going to be using this and this one. So the difference in my y values would be 1027 minus 581, right? So that's this y value minus that one. The difference in my x values would be 1980 minus 1995. So 1027 minus 581 gives me 446. 1980 minus 1995 gives me negative 15, which of course gives us a negative slope, which is what we would expect because look at your line.
It's going down.
It's going down from left to right, right? So we would expect it has a negative slope. And then we can actually divide out, since we're not going to be using the slope to graph these as far as like, rise over run and drawing it, you can actually get your slope into decimal form here. So I'm going to do 446 divided by negative 15, which gives me negative 29.73 repeated. Now, I'm just going to round that to like negative 29.7 for this point, because again, is this exact?
No.
So if it's not exact, does it really matter if I round it? No, because the whole reason we don't round things is because we want exact answers. And if our answer is already just an approximation and guess, then it's okay if you round a little bit. So I'm going to round it to negative 29.7. So that is my slope, right? Now, once I have slope, I can use y equals mx plus b, and I can plug in my slope, and I can plug in an x and a y value. Now remember, if you preferred doing point slope form, the y minus y1, so y minus one of the y values equals the m times x minus xy, you can do that here as well. You'll get the same thing. So, but I'm going to do it this way. So my y value, again, I want to use one of these 2 points because they're the ones that are closest to being on the line. So I'm going to use the first one, say. So my y value is 1027 equals my slope, which is negative 29.7 times x, which is 1980, plus b, right? So negative 29.7 times 1980 gives me negative 58,872 plus b. So we get that. And then we have to add 58,872 to both sides. So 58,872 plus 1,027 gives me, my B value is 59,899. So that means the equation for my line looks like approximately y equals negative 29.7 x plus 59,899. Now again, that's just a possible answer. If I had plugged in 1995 and 581 as my x and y values here, I would have gotten a different b, and my equation would be a little bit different. Hopefully not too different, because if we're working this properly, it should be fairly close. In fact, let's see, what time does this class end? Let's see if we can do that real quick. So there's your first equation. Everyone's got that written down? All right, now I'm going to change this. I'm going to make, instead of using 1027 and 1980, I'm going to use 581 and 1995. So I'm going to put oops, wrong pen. That's kind of big. So I'm going to use 581 here instead. And instead of 1985, I'm going to use instead of 1980, I'm going to use 1995. So in place of this. Let's see, 1995 times negative 29.7 gives me, oops, negative 59,200 and, oops, negative 59,251.5 and equals 581. So then I would add 59,251.5 to both sides. And that gives me, my B value would be 59,832.5. Is that fairly close to what we got the other way? Yeah, I mean, we're off by like 60, but considering the size of that number, a change in 60 when your value is either 59,832 versus 59,899, a difference of 60 is very minimal, right? So, this would be our equation. Now, the other thing to consider here too is our B value here is really, really large, right? I know a lot of you, when I got it, were like, whoa, because that's really big. And we're used to B being like 3 and 7 and stuff like that. Well, the reason that's big, if you think about this, this is saying, we're saying that the number of employees decreases by about 29.7 or close to 30,000 per 5 year or per year, right? Well, if you think about that, hang on one sec. If you think about that, B, this is where X is year 0. So that means from 1980, guys, wait, listen. From 1980, if we expected that it's going down 30 each year, that means in the opposite direction we expect it goes up 30 each year. Well, think if you go up 30 each year until you get to year 0. That's 1,980 years back. That's why our B value is so big there. All right, go ahead and go to your 4th period.